Hey guys, free Shavakadu, anybody? No? What? Okay, all right. Well, then I guess we'll go ahead and get into our lesson today. It's Miss Bothers, and we're going to go ahead and look at reflections on the coordinate plane. All right, now when we're talking about reflections in math, all right, when we're talking about reflections, what probably pops into your head is a mirror image. Okay, like if you see a reflection in the mirror, it's kind of the same thing with what we're about to do right now, where we're reflecting images or points on the coordinate plane. What that basically means is we're looking at the x or the y-axis basically as a line of symmetry, and again, just making a reflection, just what it sounds like. All right, so let's go ahead and look at that now. Okay, so you could be given a point such as this one right here, 3, 1, and the problem might ask you to reflect that point over the x or the y-axis. All right, well, we know that the x-axis is this horizontal line right here. It's labeled x right here. And the y-axis, of course, is the vertical axis. All right, so if I ask you to reflect this point across the x-axis, that literally means we're crossing it over x and making it a mirror image. And it's basically like saying that x-axis would be a line of symmetry. All right, so right now, 3, 1 is 1 unit above the x-axis. If I was going to reflect it, I would take that 1 unit below the x-axis. So that reflected point would be 0.3, -1. All right, if I ask you to reflect that instead across the y-axis, I'm literally flipping it over that y-axis, so it's going to cross over. Right now, this point is 1, 2, 3 units to the right of the y-axis. Well, I would go 1, 2, 3 units to the left. And so if I reflect it across y, my new coordinates would be -3, +1. All right, now let's take a look at a second example. Let's say we start with the point -2, -4, and I ask you to reflect it across the y-axis. Well, this is the y-axis here. If we're reflecting it across y, it's going literally across. It's going to cross over y. So currently this point is 1, 2 units to the left of the y-axis. So I would go 1, 2 units to the right. So if I reflect that across y, the new coordinates are going to be 2, -4. And then if I ask you to reflect this across the x-axis, it's again crossing over that x-axis. This is currently 1, 2, 3, 4 units below the x-axis. So I would go 1, 2, 3, 4 units above. So the new coordinates would be -2, +4. Okay, so you may have also noticed a pattern with the numbers when we reflected those. So as I said, one way to do this is actually use the coordinate plane and count how many spaces you would need to reflect across the x or across the y. Another way you could do it though is to actually use the coordinates because there are patterns there. So if we started, like our first example, we started with 3, 1. When we reflected across x, notice we got 3, -1. When we reflected across y, we got -3, 1. So the absolute values are all the same. Okay, 3, 1, 3, 1, 3, 1. Same over here with the second example. All of the absolute values were the same. They all had an absolute value of 2 and an absolute value of 4 for the x and y coordinates. But the symbols, or the signs, sorry, are different. So if we reflect across the x-axis, notice the x coordinate will stay the same. Okay, and then the y becomes the opposite. That happened here. That also happened over here. The axis stayed the same, and the y's became the opposite. Okay. However, if we reflect across the y-axis instead, notice that the y coordinate stayed the same and the x coordinate became the opposite. Okay, same thing here. When we reflected across y, that y coordinate, that second coordinate stayed the same and the y became the opposite. So you can use the coordinate plane and count the spaces that you need to reflect, or you can use those patterns in knowing that when we reflect across x, the x coordinate stays the same and the y becomes the opposite. And when we reflect across y, the y coordinate stays the same and the x becomes the opposite. So for example, let's take a look at these 3 points here and figure out what those reflected points would be. because you may be given a problem like this, and it will ask you what the reflected point would be, and you may not have a coordinate plane to figure it out. So you would need to know these other patterns. All right, so if I have the point -6, +5, and I have to know what it would be if we reflect across the x-axis, well, if I reflect across x, the x coordinate will stay the same. So if I reflect -6, 5 over the x-axis, I'm going to keep -6, but the y will be the opposite. All right. On the flip side, no pun intended, or maybe it was. All right. If I reflect across the y-axis, the y coordinate will stay the same. So that stays 5, but the x becomes the opposite. Okay. So again, I hope you see the patterns there. The absolute values of both coordinates will stay the same. I see a 6 and a 5, so those will stay the same. But if I reflect across x, x stays the same. Y is the opposite. If I reflect across y, y stays the same, and x becomes the opposite. All right, so for the next one, if I reflect across x, that's going to be 10, 0, because the opposite of 0 is 0. Okay. If I reflect across y, I have -10, 0. All right. On the last example here, if I reflect across x, remember that x stays the same, y becomes the opposite. If I reflect across y, y stays the same, and x becomes the opposite. Alrighty? So at this point, we've looked at how to reflect a point across the x-axis or a point across the y-axis. I also want to look at how to reflect an entire image or an entire shape across one of the axes. Okay, so I'm actually going to use the IXL standard, I think this is DD8, yep, DD8, to show you how to reflect an entire image. So for DD8, and this is under 6th grade, it says graph the image of rectangle QRST after reflection over the y-axis. Okay, so this is our y-axis here. That's our vertical axis. So if I'm reflecting across the y, it will flip across the y, and it's going to end up over here. The most common mistake is people do it the wrong direction. If you were to put it down here, you'd be reflecting it across the x-axis. So reflect this way. And the easiest way to do it on this problem would be, okay, if I'm reflecting, say, point Q across y. Well, right now it is 1, 2, 3 units away from the y-axis. So I'm going to go 3 units in the other direction. Okay. All right, then I'm going to go, let's see, in order. I'm going to do R, which, let's see. Okay, so this makes it a little tricky to show you. But R is 4 units away to the right. So I'm going to go 4 units to the left. Okay, so that's point R, then S, then T. Okay, so as I see, that is a reflection across the y-axis. I could check that by looking at the actual points and looking at the patterns there, but I can see that that is basically a mirror image where the y-axis is your line of symmetry. All right, submit. Okay, the next one, JKLM, after reflection over the x-axis. So I want you to take a minute and think about, if I reflect that over the x-axis, which way are we going to go? Okay, so think about that. Is it going to end up here in quadrant 1, or is it going to be over here in quadrant 3? Okay, hopefully you said quadrant 1, okay, because I'm reflecting it across x, which is the horizontal axis, so it will flip across that axis. All right, so I noticed that M is currently, that's at -5, so it's 5 units below the x-axis. So I'm going to go 5 units above the x-axis. Okay, so that's the reflection for point M. J is 6 units below the x-axis, so I'm going to take it 6 units above. Okay, and so this makes my square. Okay, so that is, I can see a reflection across the x-axis. Submit. All right, now for this one here, it has to reflect over the y-axis. All right, so the y-axis is this vertical axis, so I'm going to flip it across that. So if I start, let's say I start with S. S is currently 4 units away from the y-axis, so I'm going to go 4 units in the other direction. Okay, I'm going to go down 2 units for R. All right, I see that Q, let's see, if you can tell, that's at -9. So that's 9 units away from the y-axis, so I need to go 9 over here. Okay, so there's my reflection across the y-axis. All right, let me skip ahead, see if I can get a harder one. Okay, so here we go. So this one's a little bit trickier. All right, so first of all, it says to reflect it across the y-axis. So if this is my y-axis, I'm flipping it this direction. All right, so let me just start with K. All right, so I can see that K is right now, it's 5 units away from the y-axis. So I'm gonna go 5 units in the other direction for K. All right, and then L, I'm gonna go 2 units above that, okay? And it's another way to look at it is L is 5 units to the right of the y-axis, so the reflection is gonna be 5 units to the left, okay? Now for M, again, we're reflecting that across the y-axis. So if I look at M, M is currently 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. So I'm gonna go 9 units over this way. So -9. And then N. Okay, so that is a reflection across the y-axis. Okay, this one's tricky too. So let's take a look at this one, and I think this will be the last one. Actually, no. Let me do this one wrong and see what it says. Okay, so clearly this is incorrect. That's nowhere close. That does not look anything like a mirror image. All right, so I want you guys to take advantage of the way IXL will give you like instruction if you miss a problem. Okay, every time you get a problem wrong, it will show you that you got it wrong, and it'll explain like how to get it right. So it shows you, first of all, what the right answer should have been. And then it says to remember, a reflection flips a figure over a line to create a mirror image. Okay. And when a point is reflected over the x-axis, the y-coordinate changes signs. Okay. So I'm not going to go through all of this, but just please keep in mind that if you miss a problem on these, IXL will explain it in a very detailed way, so you can figure out hopefully how to get it correct. All right, so with that in mind, hopefully this helps you guys, and if not, as always, hop into one of my Zoom meetings from 11 to 12 on Tuesday, Wednesday, or Thursday, or shoot me an email and I'm happy to help. All right, I'll talk to you guys later. Hope y'all are doing well. Bye.